Okay, let's compare and interpret two or more sets of group data based on measures of dispersion. Yeah? So for example 12, we'll look at the measures of dispersion of mean and standard deviation. Okay, we'll compare and interpret what does it mean by the mean and the standard deviation that you got for two types of hybrid flowers, hybrid A and hybrid B. So let's read the example. A botanist sought 40 samples of hibiscus seeds using two different hybrids A and B. So the diameter of both the hybrids are measured under close cut to develop an extra large hibiscus. And the following frequency table shows the diameters of the petals for hybrid A and B. Okay. They are measuring the diameter of the two hybrids. So this is the classes, and these are the frequency for hybrid A, and this one frequency for hybrid B. Okay, so based on the mean and the standard deviation, determine which hybrid produces larger and more consistent petals. So we have to justify your answer. Okay, so let's look at the how to do it. So we start with hibiscus hybrid A. Start with hybrid A first. So the diameter and the frequency you just rewrite back, but in the different table. Okay, and then because you want to find the mean, so you have to find the midpoint of which will be your x, the midpoint of your here, all your classes here. You have find the midpoint. How to find midpoint? You just plus lower and upper limit, and then you divide by 2, you will get this one. Okay, so when you got all your midpoint, because you want to find your mean, so the formula of mean is fx. Okay, the formula of mean is fx, the total, the sum of fx, you divide by the sum of your frequency. So this one fx, you find your fx, 4 times this one, you'll get 52.8. Then when you get all this, you have to sum it up, and you'll get 574. And this one, your frequency also, you sum it up, you'll get this one, total frequency is 40. Okay, so your mean will be 574 divided by 40, so you get 14.35. Okay, and then now you find your standard deviation. The formula is, what's the formula of standard deviation? Okay, the sum of fx square divided by your sum of frequency minus your mean, which is squared. Okay, because you have this one x square, so you make another column for x square, and then you times it with your f, this one, so you will get this figure. This is the one that you total, this is the one that you total, and you'll get this 8253.5. This one you divide by total frequency is 40, and then you minus with your mean. Yeah, your mean is 14.35, but remember to square it. Yeah, after that you square root and you'll get this figure. So for hybrid A, the mean is 14.35 and the standard deviation is 0.64. Yeah. Okay, so let's look at hybrid B. The same thing you do. You find the midpoint and then times with fx, and then find the x square and then times with f. Your x square times with f. Then you find your mean first. Yeah, mean is the total fx, that is 564, divided by the sum or total of f, that is 40, so get 14.1. and then for your standard deviation, you take this one over total of sum of your f frequency minus with your mean here. This is your mean. Remember to square it, and then you get 0.49. Answer 0.7 centimeter. So this is for hybrid B. Yeah, for hybrid B. This one standard deviation for hybrid B. So for hybrid A just now, for hybrid A, you get the mean is 14.35 and your standard deviation is 0.6. Your A, the hybrid, is 0.64. Okay, what can you say about when you compare? Yeah, when you compare this one and this one, you can say that the size of the petals for hybrid A is larger. Yeah, produces larger petals because the mean is larger. You see, compared to 14.1, it's 14.35. It's larger than hybrid B. Okay, and this one for the standard deviation, it seems that hybrid A has a smaller standard deviation. Okay, when your standard deviation is small, meaning your data is more consistent. Yeah, more consistent. So the smallest standard deviation shows the diameter. Yeah, in this case, it's the diameter of the petals are more consistent. That's what you can say about you. This is what how you interpret. Yeah? You compare and interpret your mean and your standard deviation.